Given question, for dual cycle, heat liberated at constant pressure is equal to twice the heat liberated at constant volume. Compression ratio is 8. Expansion ratio is 5.3. Compression and expansion processes follow the law P V raised to 1.3 is equal to C. At the beginning of compression, pressure is equal to 1 bar and temperature is equal to 27 degrees Celsius. Cp is equal to 1.004 kJ per kilogram Kelvin and Cv is equal to 0.717 kJ per kilogram Kelvin. Find the mean effective pressure. Let us understand given data with the help of pressure volume diagram of the dual cycle. It is given that heat liberated at constant pressure. So, if we observe this diagram, here the heat addition process is taking place at constant volume as well as at the constant pressure. So, heat liberated at constant pressure, that means heat liberated during the process 3 to 4 is equal to twice of heat liberated at constant volume, that is the twice of heat liberated during the process 2 to 3. Compression ratio. So, process 1 to 2 is the isentropic compression process and compression ratio is V1 by V2. So, process 1 to 2 V1 is larger than V2. So, we can say that V1 by V2 is equal to compression ratio R. So, it is a notation R which is equal to 8 and which is equal to V1 by V2. Expansion ratio. Process 4 to 5 is the isentropic expansion process and the expansion ratio is given 5.3. So, its notation is RE. For compression and expansion, so if we observe for the process 1 to 2 and for the process 4 to 5, there is the law P V raised to 1.3 is equal to constant. So, we know that for compression and expansion there is the law P V raised to gamma is equal to constant, but here this is P V raised to n. So, we will consider n is equal to 1.3 because the value of gamma is 1.4. So, we will consider this n is equal to 1.3. So, when for the calculation we use the process 1 to 2 or 4 to 5, instead of gamma we have to use the term n and we have to take the value 1.3. At the beginning of compression, pressure and temperature is given. So, at the beginning, that means at point 1, pressure is P1 and which is equal to 1 bar and temperature is T1 which is equal to 27 degrees Celsius. But for the calculation purpose, we have to convert this into Kelvin, that is 273 plus 27 which is equal to 300 Kelvin. And we have to find out the mean effective pressure for this dual cycle. So, how to find out mean effective pressure? So, let us first understand what is the relation in between swept volume and clearance volume. If we observe this diagram, clearance volume Vc is equal to V2 and swept volume Vs is equal to V1 minus V2. Now, we have one relation in between V1 and V2. V1 by V2 is equal to R and V1 is equal to RV2. So, we will replace this V1 with RV2. So, RV2 minus V2 is equal to R minus 1 V2 and therefore, V2 is known as Vc, that is the clearance volume. So, Vs by Vc is equal to R minus 1. So, R is mentioned 8. So, which is equal to 7. So, Vs is equal to 7 Vc. So, this is the relation in between Vs and Vc. Now, Re expansion ratio is given, but cutoff ratio is not given. So, there is the relation in between expansion ratio, cutoff ratio and compression ratio. So, expansion ratio Re is equal to compression ratio by cutoff ratio. So, Rc is equal to, so if we transfer Rc, then it is equal to R by Re. So, R is given 8 and Re is 5.3. So, we can say that cutoff ratio Rc is equal to 1.5. So, the value of Rc we get as a 1.5. Now how to calculate the mean effective pressure? So we know that mean effective pressure multiplied by swept volume Vs is equal to area 1, 2, 3, 4, 5. So how to calculate this area? So if we observe the diagram, we have to take area under this 3, 4 plus area under 4, 5. So if I mention this area under 3, 4, so I will draw here this total area. So area under 3, 4. So this is the area under 3, 4 plus area under 4, 5. So here is the curve. So if I mention here this area under 4, 5. But we want area of 1, 2, 3, 4, 5. So we have to subtract area under 1, 2. So if I subtract this, so for this to subtract the area, I will draw here the horizontal lines. So how to subtract this? We have to subtract this area, then we will get the area of 1, 2, 3, 4, 5. So how to find out area under 3, 4? So it is the horizontal line. So we have to take P3, so we have to consider the maximum pressure, but if we observe here P3 is equal to P4. So we have to take P3 inside the bracket V4 minus V3 because the value of V4 volume at point 4 is larger than V3. So P3 V4 minus V3. Now area under 4, 5. Now at this point pressure at point 4 is larger. So we will take P4 V4 minus P5 V5 divided by n minus 1. Now instead of gamma we will use n because here is the curve. So because of curve we will use divided by n minus 1. Now minus area of 2 to 1 or 1 to 2. So for this process here is also curve. So we will take, now here pressure at point 2 is larger. So P2 V2 minus P1 V1 divided by n minus 1. So this is the formula that we have to use to calculate the mean effective pressure. Now if we observe, we have to find out pressure P3, P4, P5, P2. Pressure at point 1 P1 is given. In the same way we have to find out the values of volume V1, then V4, V5 as well as V3. But this volume is not mentioned in the question. But we have relation in between temperature and volume, in between pressure and volume, and we also have the relation that is the compression ratio, cutoff ratio and expansion ratio. So compression ratio we have relation in terms of volume, for expansion ratio also we have relation in terms of volume, and for cutoff ratio also we have the relation in terms of volume. So we will use this data and we will find out all the values. Now we will move to the process 1 to 2. So we have relation in between pressure as well as volume. P2 by P1 is equal to V1 by V2 raised to n, because for the compression and expansion we have to follow the law PV raised to n is equal to constant. So instead of gamma we will use here n. So n is 1.3. So 8 raised to 1.3 is equal to 14.9. Now P1 is mentioned in the question. So P2 is equal to 14.9 bar. So this is the value of the pressure P2 that we use to calculate the mean effective pressure. Now we will move to the process 2 to 3 and 3 to 4. Now as per the data mentioned in the question, heat liberated at constant pressure. So heat liberated during the process 3 to 4. So how to calculate this? So this is the constant pressure. So we have to use specific heat at constant pressure Cp multiplied by the temperature difference during 3 to 4. So if we observe the temperature entropy diagram for the process 3 to 4, then T4 is greater than T3. So we have to use the temperature difference T4 minus T3. So we will use Cp T4 minus T3 is equal to twice of heat liberated at constant volume. So 2 multiplied by. Now how to calculate the heat liberated at constant volume? So here we have to use Cv because of the constant volume. that is the specific heat at constant volume Cv multiplied by the temperature difference. So temperature difference is T3 minus T2. Now we will put the value of Cp as well as value of Cv. So we get the relation in between T4 as well as T3 and T2. Now we have to find out temperature at point 3. So what is the relation in between T4 and T3? So if we observe, we have cutoff ratio that is mentioned in the question. So we have calculated the cutoff ratio is equal to 1.5. So this cutoff ratio is the ratio of V4 by V3, or it is also known as T4 by T3. So we get the relation T4 is equal to 1.5 T3. Now this relation we will use in this equation. So this we will replace this T4 in terms of T3. So I will underline this. We will replace this T4 in terms of T3. Now in this equation T4 we will replace with T3, but what about this T2? Now T2 is during the process 1 to 2. So again we have to find out T2 because the temperature T1 is mentioned in the question. So we have relation in between the temperature as well as volume. So T2 by T1 is equal to V1 by V2 raised to n minus 1. Now here V1 by V2 is known as R, that is the compression ratio during the process 1 to 2, raised to n minus 1, that is 1.3 minus 1, that is 0.3. So we will get 1.86. So T2 is equal to, we have to multiply this with T1 which is in Kelvin. So 1.86 into 300, that is 559.8 Kelvin. Now we will put the value of T2. Now when we replace this T4, then we will get 1.5 T3 minus T3 is equal to 1.428 inside the bracket T3 minus 559.8. Now if we observe, this is the equation in terms of T3. Now when we solve this equation, then we will get the value of T3, and from this value of T3, here is the relation in between T4 and T3. So we will calculate the value of T4 also. We get the value of T3 869.8 Kelvin and T4 1312.6 Kelvin. Now we will find out the pressure at point 3. So we will consider the process 2 to 3. So we have relation P3 by P2 is equal to T3 by T2. So which is equal to, so T3 value is known that we have calculated and T2 we have calculated. So it is 1.55. Therefore P3 is equal to, we have to multiply with P2. So P2 also we have calculated. So 1.55 into 14.9 which is equal to 23.2 bar. So we get the value of P3. Now we will find out the temperature at point 4. So again we will move to the process 4 to 5. So T4 by T5 is equal to V5 by V4 raised to n minus 1. So this is the relation in between temperature and volume. So if we observe, process 4 to 5 is the isentropic expansion process. And how to find out the expansion ratio? That is the ratio of volume. So volume at point 5 is larger than 4. So V5 by V4 is known as the expansion ratio. So we will use here V5 by V4, that is expansion ratio RE raised to n minus 1, that is 1.3 minus 1, that is 0.3. Because for this expansion we have to follow this law PV raised to n. So 5.3 raised to 0.3 is equal to 1.64. Now we will find out the value of T5. So T4 divided by 1.64. So this T4 we have calculated. So T5 is 796 Kelvin. So we get the value of T5 also. Now we will find out the pressure. So again we will consider the process 4 to 5. So P4 by P5 is equal to V5 by V4 raised to n. So again V5 by V4 is known as expansion ratio. So RE raised to n, that is 5.3 raised to 1.3 is equal to 8.7. Now what about this P4? So if we observe here, P3 is equal to P4. Now P3 value we have calculated and which is equal to P4. So P5 is equal to this P4 divided by 8.7, that is 23.2 divided by 8.7, that is equal to 2.6 bar. So we get the value of P5 also. Now we will move to calculate area 1, 2, 3, 4, 5. So earlier we have seen the formula to calculate this. So P3 V4 minus V3. Now if we observe, we know the value of P3, P4, P2 and P1, but we don't know the value of V1, V2, V4, V5 and V3. So we will convert all this volume in terms of Vc. Vc, that is clearance volume. Now if we observe here, V2 is equal to V3 and V2 is equal to V3, which is equal to Vc. Then here also V1 is equal to V5. Now what is the V4? So how to convert this value of V4 in terms of Vc? So we have relation V4 by V3 is equal to cutoff ratio Rc, and Rc we have calculated 1.5. So V4 is equal to 1.5 V3 and V3 is known as Vc. So V4 is equal to 1.5 Vc. So we will put here 1.5 Vc minus V3 is Vc. Now plus, now we will put the value of P4 23.2. Now what about V4? So V4 is equal to 1.5 Vc. So we will put here. Now minus P5. P5 is 2.6. And what about V5? So how to find out V4 and V5 relation? So again we will move for the V5 by V4 is known as Re. So if we observe, this 4 to 5 is the expansion ratio, and V5 by V4 is known as Re, and Re is equal to 5.3. That is mentioned in the question. But this V4 is known as 1.5 Vc. Now we will multiply this to calculate V5. So V5 is equal to 5.3 multiplied by 1.5 Vc. So we will get 7.9 Vc. So I will put here 7.9 Vc divided by n minus 1. So n is 1.3. So 0.3 minus P2 V2. So P2 14.9 and V2 is known as Vc. So we will put as it is minus P1 V1. So P1 is 1 bar, that is mentioned in the question. Now what about the V1? So we have relation V1 by V2 is equal to R, and V2 is Rc. So V1 is equal to RVc and R is equal to 8. So we will put here V1 is equal to 8 Vc divided by n minus 1, that is 0.3. Now when we calculate this, so how to calculate? We have to solve first this term. So we will first solve 1.5 minus 1, that is 0.5. So 0.5 multiplied by 23.2, that is 11.6 Vc. Now we will move to calculate the second term. So first we will solve this multiplication, then this second multiplication, and then divided by 0.3. And then we will move to solve this third term. So there are total 3 terms. Then we will get 11.6 plus for the second term 47.6 minus 23. Now we will take Vc as a common term. So we will get 36.2 Vc. Now we have to calculate the mean effective pressure. So we know that mean effective pressure multiplied by Vs is equal to this area, that is 36.2 Vc. Now we have relation Pm, mean effective pressure multiplied by Vs is equal to area 1, 2, 3, 4, 5, that is 36.2 Vc. So I will transfer this Vc to the denominator. So Pm multiplied by Vs by Vc is equal to 36.2. So we have calculated the relation in between Vs by Vc. So Vs by Vc is equal to 7. So Pm into 7 is equal to 36.2, and therefore mean effective pressure is equal to 5.1 bar. Now why to take the unit as a bar? Because if we observe for the calculation of this area 1, 2, 3, 4, 5, all the pressures we have considered in bar, not in Newton per meter square. So we have to give the same unit because this is the mean effective pressure. So we will take the unit as a bar.